In this video, let us see proofs of various properties of combinations. The very first one is NC not equal to 1. We know NCR is nothing but n factorial divided by n minus r the factorial multiplied by r factorial. Now, if we substitute r as 1, r as 0, then we will get NC naught is equal to n factorial divided by n minus 0 the factorial into 0 factorial. That is nothing but n factorial divided by n minus 0, which is also n factorial, and 0 factorial we know it is 1. So ultimately it gives you result as 1 only. The next to prove is NC1 equal to n. Again, NCR is n factorial by n minus r factorial into r factorial, this expression. In that we are going to substitute if r equal to 1, then NCR will become NC1 and this will be n factorial. This will be n minus 1 the factorial into 1 factorial. And now I can write this n factorial as n into n minus 1 the factorial divided by n minus 1 the factorial. 1 factorial we know it is nothing but 1. So now this and this can be cancelled. So to get the result as n. The next to prove is NC2 is equal to n into n minus 1 by 2. That means we are going to substitute now r as 2. If we do that, we will get in the formula NCR, if we substitute r as 2, then we will get NC2 is equal to n factorial divided by n minus 2 the factorial into 2 factorial. So we can now write this n factorial as n into n minus 1 into n minus 2 the factorial divided by n minus 2 the factorial, and 2 factorial it is, we know it is 2 into 1, which is nothing but 2. Now I can cancel this n minus 2 factorial and n minus 2 factorial. So we get the result n into n minus 1 divided by 2. Next to prove is NCR is equal to NCn minus r. Let us start with the right hand side first. Right hand side is NCn minus r. If I expand it using the formula, we get n factorial divided by n minus of n minus r the factorial into n minus r the factorial. That can be written as n factorial divided by, if I take the negative sign inside the brackets, we get n minus n plus r the factorial into n minus r the factorial. That is nothing but n factorial divided by n and n gets cancelled. We get r factorial into n minus r the factorial, which is nothing but NCR, and that is our LHS. Next, we need to prove NCn is nothing but 1. We are already seen NCR is nothing but NCn minus r. So applying that, we can say we know NCR is NCn minus r. So here the left hand side, which is NCn, that can be written as NCn minus n, and that is nothing but NC naught. And we already had seen NC naught is nothing but 1. That is our desired RHS, hence the proof. Next to prove is NCR plus NCR minus 1 is equal to n plus 1 CR. So let us take the left hand side and expand it. If I expand NCR, it is n factorial divided by n minus r the factorial into r factorial. Then if I expand NC r minus 1, it is n factorial divided by n minus of r minus 1 the factorial into r minus 1 the factorial. Now we may notice that n factorial is common. We can take it outside, and inside I can write it as 1 by n minus r the factorial. R factorial I can write it as r into r minus 1 the factorial plus Already I took n factorial outside, so I can write 1 divided by, and if I take this negative sign inside the brackets, it becomes n minus r plus 1 the factorial into r minus 1 the factorial. Now we may notice r minus 1 factorial is common in this. We can take that outside in the denominator. So n factorial divided by r minus 1 the factorial, and then inside the brackets we have 1 by n minus r the factorial into r plus 1 divided by this n minus r plus 1 the factorial can be written as n minus r plus 1 into n minus r the factorial. Already we took r minus 1 the factorial outside, so we need not write it again. Now in this, you may notice in the denominator n minus r the factorial is common, which can be taken outside. N minus r the factorial into r minus 1 the factorial, and now you will have 1 by r plus 1 by n minus r plus 1. Now if we take LCM for this, we will have n factorial by this, as it is we will be writing. Now LCM is r times n minus r plus 1. So here we will have n minus r plus 1, and here we will have plus r. Now this negative r and positive r get cancelled. So numerator, you may notice here it is n plus 1 is available. Already there is a n factorial outside. So n plus 1 into n factorial is nothing but n plus 1 the factorial divided by, here we may notice r is there, r minus 1 factorial is there, that can be written as r factorial. Then we may notice here n minus r plus 1 is there, n minus r the factorial is there, which is nothing but n minus r plus 1 the factorial, right? Now what is this? This is nothing but, I mean, if we want to write this, this is nothing but n plus 1 CR. That is our desired right hand side. Next we need to prove NCR is nothing but n by r times n minus 1 CR minus 1. Let us take the left hand side, which is NCR, and that can be written as n factorial divided by n minus r the factorial into r factorial. Now this n factorial can be written as n into n minus 1 the factorial, and this r factorial in the denominator can be written as r into r minus 1 the factorial into n minus r the factorial. That can be rewritten as n by r times. Now if we look into this expression, that is n minus 1 factorial divided by r minus 1 factorial into n minus r the factorial is nothing but n minus 1 c r minus 1. That is our desired right hand side. Next to prove is n times n minus 1 c r minus 1 is equal to n minus r plus 1 times n c r minus 1. First let us take the left hand side, that we can write it as n times n minus 1 c r minus 1 is n minus 1 the factorial divided by n minus 1 minus of r minus 1 the factorial into r minus 1 the factorial. And the numerator, I can now club this n into n minus 1 factorial as n factorial divided by this one minus 1 gets cancelled. So you will get n minus r the factorial and into r minus 1 the factorial. Let us consider this as equation 1. Now let us start with the right hand side. which is n minus 1, sorry, n minus r plus 1 times inside the brackets, it is nc r minus 1, which can be written as n factorial by n minus of r minus 1, the factorial, times r minus 1, the factorial. So now we can rewrite it as n minus r plus 1 times n factorial divided by, denominator now becomes n minus r plus 1, the factorial, into r minus 1, the factorial. Now, in this, the denominator can be splitted as, numerator will write it as it is. Denominator can be splitted as n minus r plus 1 times n minus r, the factorial, into r minus 1, the factorial. Now, this term and this term can get cancelled. We will call this as 2. We may notice that, note that 1 is equal to 2. Hence the proof. Next, to prove for any positive integers x and y, if ncx is equal to ncy, where this x and y are not equal, then we need to prove that x plus y equal to n. We know that NCR is nothing but NCn minus R. That means NCX can be written as NCn minus X. Now this NCX is already given as equal to NCY, so I can equate this to NCY, which means I can equate now these two suffixes, means n minus x and y. That means n minus x equal to y, which implies that n is x plus y. Hence the proof.